Alright, hello. Today I'm gonna show some tricks with this Wireshark and Firefox. So I have a switch here, which I'm going to log into. Even though it is an HTTPS here, I'm going to try to decrypt this recorded session. But first I'm going to record this, and I have some virtual interface. This is the virtual interface. La la la. This goes over a tunnel, so we're a little slow. I had to create a tunnel just because I didn't have the patience to fix the routing. Right, it's recording. Log in as admin and a very secret password. And I'm in. So stop the recording. So here, as you can see, it's encrypted and I can't see anything. The first thing that happens is that the client, which is my browser, sends a client hello package. And if I expand this, I can see a little bit what's inside this hello package. It's a handshake protocol, client hello, and this handshake protocol contains something that's called cipher suits, or suites, or however you pronounce it, and it's has these long strings, 23 of them. So the first part of the string is a proposal for how the key exchange should be done, and this is how when you have established a session key, this is how the rest of the session is going to transfer the encrypted packets, and this last thing is what hash algorithm that should be used for message authentication codes, or HMAC, or whatever it's called. So, and that's basically to ensure that no one is tampering with the packets while they travel through the internet. Alright, so the client sends a proposal, says I support all these 23 different cipher suits, and then the server responds, well, I'm gonna choose this one. And this is not a very good choice because it doesn't have Diffie-Hellman in here anywhere, no DH. So DH, or rather DHE, is something you should look for. The E stands for ephemeral, and that gives forward secrecy. And what that is, I'm just going to show you now, because if I go back here, somewhere I have a window. Here, I'm actually logged into this unit, and I happen to know that the private key of the server is in. Alright, here's the private key. And this is not the default private key, I just created it now. And I can put it on my computer here and paste this in. Okay, now it's in key.pem. Alright? Now I can go back to Wireshark. I have my recorded session. Where's Wireshark? Here. And if I go into settings here and then choose protocol SSL, let's see, it takes a little while for the graphics to traverse the tunnels. Choose SSL. SSL. And here's the RSA key list. So I can add a new one. And I notice the IP address of the target is port for HTTPS is 443, and the protocol is HTTP once it's decrypted, and the key file should be key.pem here. Okay, now I choose the correct one. I think everything is correct here. Apply. Okay. Now, if everything is correct, if I check here, see that was something green here. It has actually decrypted. something. This green thing here wasn't here before. So it has taken this, if you just follow this TCP stream, you're going to see encrypted traffic. And blah, 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 blah. But if I follow it as an SSL stream, it is decrypted because I entered the server's private key, and then Wireshark can calculate everything it needs to decrypt the entire session. So here it is. So and it even presents the decrypted packet to me here in the HTTP protocol as I specified. So I can even use Wireshark to go in and see what happened. It was the form action login, and the item username or uname was admin, and the pass was secret. So now I have sniffed the password over the internet over an encrypted channel, but because I managed to extract the secret key from the firmware, I was able to decrypt it. Now let's see what happens if I change the parameters of the web server to use Diffie-Hellman instead. Okay, this is really fast. Okay, I have on this virtual interface, I have the address switch. Continue without saving. Clear this. Right, now it's capturing. I want to go to Firefox and go to 1.1. Okay. I have another password there, it's not the same. Go to Wireshark and I can stop. Now I have recorded this. Now let's see what's happened here. We have the client hello. It sent the cipher suits, 23 again, it's the same 23 ones. And then the server chooses one. And now it has DHE here, which stands for Diffie-Hellman ephemeral. And now even if I manage to get my dirty hands on the private key of the web server, I cannot decrypt this. Let's see if I try to do this. Okay, so I have a new private key. You can see it's not the same one. You can call it key2.pem. Go back to Wireshark and enter this new key. I think there's a short way to get to this. Right click, protocol preferences, RSA key list here. So now I can add a new one. Open. And now, even if it got this key, well, it can try to follow, but it will be empty. And if I go down here, it should be no green lines. Green lines means decoded HTTP packets. And everything is encrypted. Alright, so to see how you should configure, go to this address, bettercrypto.org, and check this applied crypto hardening guide. So if you have, for instance, the Apache web server, you can go here and see. In the Apache configuration, this is the magic line, SSL cipher suits. So this is a string that hints in which order the server should choose among those cipher suits that the web client has told the web server that it supports. So this actually only supports new clients like Firefox, Chrome, new versions, and Internet Explorer 10 and up, but not Internet Explorer 8. So to support Internet Explorer 8, here, older clients. So here is the string to use with older clients instead of the longer string. So this actually will choose those cipher suits with high security first, but if the client doesn't support any of them, it will roll back to these with low security, like this without forward secrecy. And there is actually an attack where a man in the middle can go into the first client hello packet and modify the cipher suit list that stop talking, go to the hello packet. Here, the client hello packet. And if there is a man in the middle between the client and the server, the man in the middle can take this packet and modify this cipher suit list and remove all that has DHE here, and only leave the other ones in. And that will make the server respond with one of those in the server hello message, and you will have no forward secrecy. So that's called a cipher suit rollback attack.